Okay, Math 2 9.9, circle segments. So by segments, I'm talking about the chords and the secants and the tangents. And this time we're talking about the length of them. So starting off, I think the one on the right is the easiest. If we have two chords that intersect, then where they cut, then each piece multiplied together are equal. So AB equals CD, right? So we're talking about the chunks of the same chord multiplied together, right? A and B go to the same chord, right? And then C and D go to the same chord. So there's one formula for us. And then we have two other formulas. And well, let's look at the middle one first, the one right here. So we have our formula is B and then A plus B. So B is this piece here, and then A plus B is the whole thing. And then we have D and then C plus D, the whole piece. So we have the small times the whole big, or you could say the outside times the whole thing. I'll say that. Outside the outside times the whole thing. And that's what we do for both of them. All right, and then lastly, so the one that we just talked about had two secants, right? They're like chords that are extended. Here we have a secant and a tangent. So the c squared says the tangent squared, and then we have b, the outside, and then a plus b, the whole thing, right? So it still follows that outside times the whole thing. And really, if we think about it, the c is the outside, and then c is the whole thing. So we still could use this outside times the whole thing kind of way to remember it. So this is the way that I remember it. Outside times the whole thing. And that works for both of these formulas. All right, let's dive in. Number one, here we have our tangent. Here we have the outside of a secant, and then here's the whole thing. So the whole thing is going to be x plus 27. So let's start off with the tangent piece. So we're going to have 45 squared. That's our tangent. And then the other thing is going to be the outside, which is 27, times the whole thing, which is x plus 27. So let's type this in. We got 45 squared, which is 2025 equals, and I think I could divide by 27. Yeah, I'll just leave 27 and then x plus 27. I'll divide everything by 27 now, and I get 75 equals x plus 27. And whenever I subtract 27 to the other side, I get 48 equals x. And what am I looking for? It's a solve for x, so there I am. All right, number two. Again, we have a tangent here. We have the outside piece of our secant, and then we have the whole thing. So the whole thing is going to be x plus 8. So starting off with our tangent, I'm going to have, well, 12 squared equals 8, the outside, and then x plus 8, the whole thing. So 12 squared is 144. Then I'll divide by 8, and I get, well, 18 is x plus 8, so 10 is x. Right, not too crazy. Right, and remember I said this 12 squared, you could remember that as the outside times the whole, right? Because the outside is 12 and the whole is 12. Or you could say the outside is, for the other one, we'd say, well, the outside is 8 and the whole is x plus 8, right? So remember that. That's a good way to remember it. All right, moving on to number three. Number three, these are chords that intersect inside it. So we have the first chord, here's a piece, and here's a piece. And then we have the other chord, here's a piece, and here's a piece. Right? Now let's look back at our formula for just a second. So we have A and B, A and B. They go to the same chord. right? That's something that's sometimes hard to remember. Same chord. So we're going to do the two blue pieces and then the two green pieces. So I'll say, well, 18x times 14x equals 12 times 21. So I'm going to leave this at, well, I'll type that in. 18 times 14 gives me 252, and then we have x squared. And then 12 times 21 gives me 252. Well, that's nice. I divide by 252, and x squared is going to be 1. I take my root, and x will be 1. Remember, we normally, whenever we take a root, we have to have a plus or minus there. But because we're talking about geometry, and it doesn't make a whole lot of sense to have a negative, we're going to leave it as just 1. All right, what was I supposed to find? Still x? Yep, all right, so we're good. Number 4. So we have, how do I want to draw this? Outside and the whole thing, and then we have another outside and the whole thing. All right? So I'll start off with the top one with the 10. So 10 is the outside. The whole thing is 10 plus 8. Then the other one's going to be the outside, which is 9, and then the whole thing, which is 9 plus x. So this is 10 times 18 equals 9 times 9 plus x. So if I divide by 9, I'd have 10 times 2 is 9 plus x. So 20 is 9 plus x. So 11 is x. All right, let's move on to number 5. So here's our outside, and then also our whole thing. The other one, here's the outside, and here's the whole thing. So I have x squared for my tangent piece, and then the outside is 9, and the whole thing is 16 plus 9. So I'm just going to type this in, 9 parentheses 16 plus 9. That gives me x squared is 225. Whenever I take a root, my x is going to be 15. And again, I should be using a plus or minus here, but a negative distance doesn't make sense, so we're not going to use the negative piece. Number 6, we have our chords. Here's our first chord and our second chord. So I'll start off with the one with the 14 and the x. So I'm going to say, well, 14 times x equals 16 times 21. So 14x equals 16 times 21 is 336. Whenever I divide by 14, I get x is 24. All right. Always remember that we use the same chord. We use the cut chord. All right. Number 7. Here we have a tangent and a secant. So I'll start off with my tangent. I'm going to have, well, 36 squared. And then for my secant, I have the outside, which is 27, and the whole thing, which is 27 plus x. So 36 squared is 1296, and 27 times 27 plus x. And we could, if we wanted to, we could distribute that, but I just think the numbers stay a little bit smaller if we don't, so I'm not going to. So whenever I divide by 27, I'm left with 48 equals 27 plus x. I subtract 27, and I get, well, 21 is x. All right, number 8, last one. My tangent is 6, so I'm going to say, well, 6 squared equals the outside, x, and the whole thing, x plus 5. So 36 equals. Now I'm not going to be able to divide by that x. Normally I would divide, let's look back at number 7. Right here I divided by 27. I'm not going to be able to divide that x. So I'm going to go ahead and I'm going to distribute it. So I'll have x squared plus 5x. So now we have a quadratic equation that we're going to have to solve. And some of these will be kind of long solving at the end. Yeah. So I will set it all equal to 0. So I'm going to have, well, x squared plus 5x minus 36 equals 0. And to try to solve this, we remember that we could try to factor this. So I want to look for factors of 36. Is there anything that could break up to be 5? The only factors of 36, I could say, well, I've got 6 and 6. Or I could have, what is that going to be, 3 and 12. Or I could have 9 and 4. Well, if I took 9 and 4, I could make a 5 out of that. 9 minus 4 is 5. So this is going to be x plus 9, x minus 4. We solve this, we say, well, x plus 9 is 0, or x minus 4 is 0. So x is negative 9, or x is 4. Well, we've already talked a few times about how negative distances don't really make sense, so our answer is 4. All right, there we are.